So, first, just briefly introduce yourself.
Okay, yeah.
Yeah.
I'm Erin Schliep, an assistant professor at the University of Missouri.
Okay. And I'm Lara Harmon from the ASA, and I will be asking Erin questions today with Donna LaLonde, who's over there on the side for me. Okay, first question is, so it's not a question, it's more an invitation for a narrative. So tell us about your educational and career journey that brought you to your current position where you are.
Yeah, perfect. So I did my undergraduate work at Gustavus Adolphus College, which is a liberal arts school in South Central Minnesota. And I was actually a double major in mathematics and accounting. And so I took a lot of math classes and took a lot of accounting and business classes throughout my 4 years there. And really what that led me to is a job as an accountant. So I spent about 1.5 years working for the Minnesota Office of the State Auditor, where I served as an auditor that we audited government agencies, so counties, school districts, fire departments, the Minnesota State High School Athletics Council, things like that. So after about 1.5 years, I realized that maybe accounting wasn't the end-all, be-all for me, as I didn't have the ambition to pursue the CPA and the different sort of hurdles that were in the way for that. And so I applied to graduate schools in statistics, with really the main intention of getting my PhD and then returning to a liberal arts school and teaching. Turned out that throughout my time at Colorado State is where I ended up getting my PhD and my master's degree as well. And through my time there, I had the opportunities under the direction of two of my advisors, both Dan Cooley and Jennifer Hoding, to work on a handful of collaborative research projects. So they span things in the biologies and the ecologies, natural resources, atmospheric sciences. And through all of those different experiences, working with collaborations sort of across campus and across Colorado in general, within government agencies as well, I realized that I didn't want to just pursue teaching. I wanted to pursue research and teaching. And so to sort of continue on my career in that avenue, I accepted a postdoc at Duke University for 2 years, working again at this interface of statistics and environmental sciences. So I had advisors Alan Gelfand and Jim Clark, who are part of the statistics and the Nicholas School of the Environment at Duke, to sort of just continue on doing research in environmental statistics. And so at the end of that 2-year postdoc, where I focused on research, not teaching and research, I was ready to apply and ended up landing this job at University of Missouri, which is sort of a perfect fit for me in terms of environmental statistics, spatial temporal statistics, etc. And so now I've been here, I guess, for about 3.5, almost 4 years in this position.
Well, thank you. I think not many people, at least lay people, think about accounting and statistics. I certainly didn't.
I definitely did not mean for them to sort of go together.
Yeah.
I think it was I liked the business aspect and I liked the math aspect, and I definitely was my interest lie in really applied statistics in general. And so I think that's maybe where I brought the connection. Again, I could work in financial statistics as well. So there's areas of statistics that I also could have more, I guess, collaborations with people in accounting, but I haven't gone down that path really ever since I left my auditor job in pursuit of my PhD and now as a faculty member.
Erin, was the focus on the environment because of the initial projects at Colorado rather than going the financial mathematics route, or?
Yeah, in fact, entirely. It really stemmed up that's where the opportunities came to me when I first started out, but also that's the areas that my friends were in. And so there's a lot of connection between the statistics department, the math department, and their graduate degree program in ecology. At Colorado State in particular. And so that's just sort of where my cohort of friends and people that I knew were in, and just kind of my interests sort of stem from their interests, I guess, in many ways. But I think being outdoors and sort of like-minded with that group of people, it just sort of became a natural fit.
Colorado is a very outdoors place.
Yes, exactly. Very much so.
Okay, are you ready for the next one?
Here we go. Yeah.
All right. Is there a class or classes that you didn't take in college that you wished you had?
Yeah, so as I just got done saying with my double major, I ended up spending a lot of time taking accounting and business classes in general. And so I definitely did not have the opportunity to take as many outside of my degree area classes as I would have liked. But I recently went back through the Gustavus Adolphus course listings because I knew that there was definitely some departments that I'd be interested in, and particularly within, say, the environmental studies or atmospheric sciences. And I came across 2 classes that I thought would have been fantastic. At least knowing what I wish I knew coming into sort of what I'm doing now. One of the classes was a class in surface processes. So it looked at like weather systems and streams and glaciers, groundwater, ground ice, tectonics, volcanoes, etc. And again, that just sort of would open up sort of a big picture of things that are happening on the Earth. And I think just knowing how some of those processes exist and how they've been changing would be a big thing to know as I've sort of continued in this realm of environmental stats. The second one, and maybe even more closely applicable, it'd be a class in remote sensing. And so a lot of the statistical methods that I've worked with my collaborators on developing have used data from remote sensing technologies. And so, I mean, one of the important things in stats is not only knowing how to write down the model and obtain inference, but also understanding how the data were obtained, right? Because that's a big component of when you start specifying, right, just sort of the modeling parameters and the uncertainties associated with the data that was being collected. And so having a broader knowledge on different types of remote sensing, I think would have been extremely useful. And right into that comes into some of the software and the GIS technology and such that would have been useful 15 years ago.
So you mentioned GIS. Could you kind of briefly name a few of the remote sensing tools just so we kind of have an idea if no one knows?
Yeah, great. So they could be things that like LiDAR or other sort of devices that fly underneath the bottoms of airplanes as they go across fields and they're surveying forest or agricultural land, for example. But also other ones would be that are on satellites. So Earth orbiting satellites that are observing sort of so many different Earth and surface processes in terms of temperature and water temperature, sea surface temperature, and then obviously the air quality metrics, and different ozone concentrations, et cetera. All of those things I've worked in as a statistician, but it would have been great and it would have been easier than learning on the fly as I have how these sort of technologies are in fact used and could be sort of that knowledge could be incorporated into the statistical side of the equation for sure.
Thank you. It always changes what's being used. So
yeah, absolutely.
Ready for the next one?
Yep, for sure.
Okay. What does a day in your life look like? A work day, I'm assuming.
Yeah, absolutely. So I'm, ever since living in Colorado, I'm a bike to work person. So it starts off with a bike ride into the office. And then depending on whether it's a teaching day or a non-teaching day, is different, but I teach primarily on Tuesdays and Thursdays. So Tuesdays and Thursdays are my teaching days where I have office hours and meetings with students in my class and obviously then my classroom time. Non-teaching days are usually either meeting days or days that I've reserved for my own research. And so that's one thing that's just been a major, very important aspect, especially as an early career statistician, is making sure to preserve your time to get research done that's uninterrupted time. So it's easiest if you have a big block of time where you don't have, every other hour schedule of meetings where you can get nothing done between those meetings. So depending on the day, if it's a Wednesday, that's primarily my research day. And so I try to sort of lock myself in on those days and avoid as much email and contact with students and other faculty meetings as I possibly can. But otherwise, yeah, it's spent really, giving my lectures or preparing my lectures or getting ready homework assignments or things for my actual class, and then having meetings with collaborators. And so those days usually, I currently have collaborators both here at Mizzou, but also across the nation and sometimes across the world, depending on where people are traveling to. So there's a lot of Zoom calls and Skype phone calls and big group collaborative projects where right now it's the 3 of us on the Zoom call, but sometimes we have 30 of us on a Zoom call. And so trying to organize how some of these big sort of NSF projects are moving forward is also definitely fills up some of my time.
Erin, could you say a little bit more about one of the cooler projects that you're working on? Share a bit more with us about what the project is.
Yeah, so one of the big NSF funded projects that I'm on is studying lake water quality in inland lakes across the United States. And so we're sort of first phase of the project is collecting data from literally like 160,000 lakes across the United States and bringing this into one big database that we know have the measured nutrients like nitrogen and phosphorus, for example, in these lakes, as well as the surrounding area could be leading to changes in how these lake nutrients are maybe varying through time. So things like land use, for example, or temperature are primarily the things that are affecting those different nutrients. And so, yeah, this project is looking at taking the observations that we have, sort of spanning, like I think this number is like 87 different agencies that have gone about collecting this data. So you have the government agencies and the academic institutions, and then also sort of other sort of local tribes that have collected some of the data. So bringing them all together and then trying to pull them sort of in a collective effort in order to see how these things are changing or how they're varying across the landscape. And for those lakes that we're unable to visit, is there information from the ones that we are that can be used to predict the ones that we aren't? And so it's sort of this big collaboration between limnologists, or those who study lakes, with some of the ecologists, and then statisticians and computer scientists sort of come together to try to sort of inform on lake nutrients and possible ways that they might be changing under different climate change scenarios. Yeah.
So how is it that you learn enough ecology to collaborate, right? So I'm just always just amazed at the language that there is within a specific domain. So how do you learn to talk to your collaborators?
Yeah, sometimes I'm more successful than others, that is for sure. But you really have to want to. You have to want to be able to communicate, right? Because when I meet with those that are outside of statistics, there are some statistics words that I definitely don't use when I'm communicating with them. And there's obviously things that in their world that they might not say to me because I'm not going to understand it. But it just is continually asking questions. It's a back and forth. I don't know what you're saying, and being comfortable saying, I have no idea what you're talking about, just to be able to get them to sort of explain it on a different level. Or you have this as in teaching as well, right? You have to sort of read your audience and sort of what parts are they picking up, where are they having questions, to try to explain it again and sometimes again and again. And I'd be the first to admit that in a lot of these topics, had you asked me this before this project started, I knew nothing about nitrogen and phosphorus in lakes, right? And so now I'm slowly picking up some of the terminology with nitrogen cycling and the importance of agricultural land on the changes of these nutrients. And just even the way that the data is being collected. For example, Secchi discs is literally a bullseye-looking disc that they drop into the lake when they're out on a canoe, and they measure how far it goes down before they can no longer see it. Right, so that's the depth, right? Secchi disc depth is what the column is listed in my data set, but had I not known that, that was just another variable. So it's sort of just from being interested in wanting to continue to learn. Like I love learning about some of these things that I never would have explored prior to now. And these are even things that you might not have learned just in your traditional, environmental studies or environmental science classes. Because just some of it you learn when you're in the field. And I consider some of my collaborative conversations like being in the field, but sort of learning about some of these different technologies, different ways that they sort of just talk about it.
I love the tools scientists use.
Yeah.
It's always really interesting to figure out how they actually do stuff.
Yeah, absolutely. Yeah, and in practice, right? And they usually you ask them, how accurate is that really? And usually they have a pretty good answer on either, pretty accurate, or some people are better than others. Exactly.
It's cool. I love that. You just have to watch it. Like, I can't see it.
Yeah.
All right, Donna, do you have any more questions before we move on?
Well, this is totally off the topic of statistics, but as a cyclist, I'm really curious, how far is your bike commute and what do you ride?
Great question. Yeah, so my bike commute is currently about 3 miles, up one very big hill on the way in and down one very big hill on the way home. Right now I just have a commuter bike, a Cannondale Quick 4 to be exact. But on the weekends when I actually have time to get out, I ride a Cannondale CAD 10 road bike. So I'm of the Cannondale fleet right now.
Good choice.
Thank you. Thank you.
All right. Ready for the next one?
Yep.
Okay. So we've kind of moved a little bit into this, I think. But what is the I can speak. What is the coolest thing about your work and your research? Let me say that again. What is the coolest thing about your work and your research?
Yeah, so we sort of touched on that a little bit because I think you sort of can recognize that I'm passionate about the collaborations. And so I think the collaborations and just learning about the different areas of science that statisticians are currently being involved in. Again, mine are primarily focused on environmental applications, but they definitely wouldn't need to be. But some of these collaborations span from, during my postdoc I was working on, or during my graduate degree I was working on understanding or evaluating the condition of wetlands in northern Colorado. I've done some projects with people at NOAA looking at social behaviors of dolphins and whales. Again, I don't know a lot about dolphins and whales other than what I've learned about through that project. A lot of the work I did when I was at Duke was looking at estimating carbon in forests through a lot of the foresters down in North Carolina. Another big project that I worked on in North Carolina worked with some people at NC State who set up a bunch of camera traps, and these camera traps take pictures whenever an animal walks in front of it. And so it's like a citizen science project where then people go in and they identify what species of animal it was, and they're interested in understanding whether or not different species were co-occurring, meaning did these species actually see each other on a day-to-day basis. We talked a little bit about the nitrogen examples. So I've talked with a lot of people that are studying limnology. And I have collaborators up in Minnesota looking at fish populations and so predator-prey fish populations and how those might be changing in some of the Great Lakes in the Midwest or upper Midwest. And then those projects that stem from looking at air quality metrics from satellite data. Right? So again, so many different areas that statisticians can get their hands in, and you just continue to learn about areas of science that are so interesting, and you can still be passionate from the statistics side. You can apply it to sort of whatever area you're interested in. Out of all those projects, probably if I had to pick a favorite, and again, I don't know if I can pick a favorite based on purely the stats behind it, but whenever you get the opportunity to visit a research site, that's fun, right? So now you get to see actually on the ground where these scientists are doing their studies, right? Where are their field sites? And so our team went down to Puerto Rico for a week during the winter, our winter, and it was beautiful. And we got to explore the environmental gradient across the island, right? You have the extreme sort of high precipitation regions in the northeast versus the very dry region in the south. You can see how the vegetation there varies dramatically based on that elevation change and really how the systems come across that particular region. And so when we were there, it was about a year and a half before the hurricane came through. And so after that hurricane, we were able to see some of the pictures afterwards, and you really saw the devastation of the island that it incurred after that big hurricane. So again, this sort of travel aspect, but getting an opportunity to actually now spend time in the field with your collaborators that really know the environment and just get to tag along with them, that's pretty fun.
I know someone who does that, so I've heard those stories. And yeah, it always does sound like a lot of fun.
Yeah, I don't know how long I would survive at a field research station.
Yeah.
Cold showers only go so far for me, but it was definitely fun for the week that we were down there. Yeah.
And I just love to hear about scientists from non-scientists' perspective and what they get up to.
It was an experience. We were out on a hike one day, and a tree limb broke off of a tree that was near where we had been staying, and it fell across the rental car. And so there's a huge dent across the hood of the car. We had a whole experience of taking scientists, non-outdoor scientists.
Yeah, I meant to say that, yeah. But non-field scientists and field scientists.
And I was one of them, yeah.
Yeah.
It was good though. It actually makes you really understand what you're doing on a completely different level. And so really I would argue that all statisticians should have a field day with every project. It should really, if it's plausible, to really see exactly how this process works. And that's actually some of the advice that I got from my advisor, Jennifer Hoding, back in Colorado, where she was giving opportunities to go out and tag the deer when they're studying chronic wasting disease. So now they're flying in on a helicopter and they're dropping down and they're collecting the data and they're tagging the animals. And I mean, this is not something you necessarily need to do to be a statistician, but I think it makes you really appreciate when you start questioning why they didn't do a better job collecting their data. You appreciate that it's not always possible to do so.
I think that sounds like quite good advice. To have a perspective from all levels. Yeah,
especially if you like to be outside. Why
yes.
not? Right. Another reason why I'm in the environmental stats world.
Makes sense.
Yeah.
All right, Donna, do you have any extra questions?
Nope, I'm good now. Thank you.
All right, are you ready for the next one?
Okay.
Oh, I think we have covered a little bit of this one as well. So what do you like to do when you are not working on research or teaching?
Yeah, or riding my bike. I think just literally being outside and being active is sort of what I do most of the time when I'm not sitting literally in this chair teaching my students. And so that includes biking, but running, hiking. A lot of hiking when I lived in Colorado, and even actually here in Missouri we have some nice hiking trails. And I'm actually a golfer, so I spend quite a bit of time on the golf course when I can get away for a sort of entire Saturday. That's a little bit harder for me to do right now than just going out for a quick run or bike ride, but playing golf is also a passion of mine as well.
Do you compete, Erin? Any running, racing, or cycling racing, or duathlons, triathlons?
Yeah, so I'm primarily a runner when it comes to racing, and so I would say the half marathon is probably my favorite, but I did run my first marathon, first two marathons, I guess, in 2018, and I'm looking forward to not running another one this year. But it was good. It was a great experience, and I think it's just if you are passionate about running, it's great to get outside. I do the sports of the triathlon, so I enjoy sort of swimming and biking and running, but I've never actually competed and put them all together. I'm still a little bit terrified of the whole changing transition idea, but it will happen. It just hasn't happened yet. So
as a runner, I just have to ask, where were the marathons?
Yeah, great question. So I grew up in Minnesota, and my parents met at University of Minnesota Duluth. And so the first marathon I did was Grandma's Marathon up in Duluth, Minnesota. So that was just this past June. And about a month prior to that, roped in with some friends here in Missouri. I ran the Berryman Trail Marathon in South Central Missouri, part of the Ozark Trail. So that was a completely different experience, all single track trail for 26.2 miles. At the end of that one, I also said, I think this is a never again for me, but you never know. It's fun. You're outside, you're sort of being active. And so it's hard for me to say no to those types of things if the opportunity should come around again.
Yeah, I understand the Grandma's course is very beautiful. So that's wonderful.
Yeah, interestingly enough, that's one of those races where you run right along Lake Superior the entire way. And by about mile 16, you see the bridge, which is downtown Duluth. And that's sort of the iconic sort of symbol of Duluth, and you see it for 10 miles running towards it. Although the marathon 2018, it was 50 degrees and foggy, never saw the bridge, barely saw the lake. And so totally different. I don't know if that's helped or hurt. So the running conditions, the temperature was perfect, but it wasn't maybe the exact experience that people have had in the past. Maybe why I'm thinking about doing it again, but again, not this year.
I've watched runners get other people to run. It's hard to say no.
Yeah, it very much is. It's easy to get people to commit to it because you just tell them how great it's going to be, and the competitive nature, I think, jumps in, and you're like, okay, let's all just do it. And you sign up, and now you're doing back-to-back races, and the excitement kind of gets you there, and the adrenaline gets you there.
All right. Donna, do you have?
I am not going to start down the running path, or we would be talking about our favorite races for the rest of the day.
I understand that. I understand.
Yes, absolutely. Although I have to say that I'm liking the trails a lot these days. So I totally advocate another trail race for you.
Yeah, absolutely. It's a different deal altogether. Different mentality, different competitive component to it. I definitely don't race those as seriously as I would race a road race. So it's much more for the social aspect for me, and I think that's probably a healthy way as we get older. So.
Okay, are we ready for the last one?
Yeah.
Okay. What question that we didn't ask would you like to answer?
Yeah, so the one thing I think that's important to know is that even though through this entire interview discussion so far, I've been talking about environmental statistics, you definitely, as a student or as someone kind of coming up into this career of statistics and applied statistics in general, is that you definitely don't need to stick to one. And it's interesting how similar they are. So the question would be, are there opportunities for statisticians to work sort of in more than one area, so not just say environmental statistics? And the answer is absolutely yes. And it's amazing to me, even as I sort of have continued my career, to see some of the connections from different areas. We have obviously seminar speakers come through the academic setting all the time. You see some talks that aren't in your application area that are definitely tied to or somehow tangentially related. And so some of the work that I've done with, say, dolphins and whales borrows from the idea of social networks, which then extends into sort of looking at Facebook and Twitter and how those sort of social networks have evolved or changed through time. Currently at Mizzou, we're working on developing a sports analytics program. And so you might say, environment, sports, right? I don't see the connection, but think about animal movement models, right? We watch geese fly, right? We watch animals move across the landscape, and they're responding to one another. Same thing as soccer players as they run around a soccer field, right? So how can we borrow and look at some of the models and methods that would be used for one area and notice that they directly apply to other areas, just looking at some sort of different objective where animals might be trying to pursue higher ground or food, and soccer players are trying to get a ball into a goal, right? So a lot of these areas really sort of stem. To take that even maybe one step further, much of the methods that have been developed even in the past 10 to 15 years in spatial and spatial temporal stats have dealt with big data, right? So high frequency time series data or spatial temporal data that have been collected and how to monitor those or model them. And you can take that and now think about athletes, and you've got the GPS trackers on them, and you've got their heart rate monitors on them. There's, again, is high frequency time series data on these individuals as they run around a soccer field and how their heart rate or maybe other biometric things are responding. Take that into that extends right then to precision medicine, right? How should we be training our athletes in order to sort of tailor their programs and their recovering to increase the performance of both the individual and the team? And so there's so many connections between all these different areas. And as you start learning more and sort of building up this toolbox of methods and models to use at them, it's very sort of easy to start seeing some of the connections. So there's no reason to just stay in environmental stats if you have passions across sort of as many areas as you want. So I'd sort of argue that if I wanted to get back into accounting, there are ways to start thinking about, the current experience I have right now with, forest biomass, right? Some of the methods and models and things that I've learned from these particular experiences and opportunities, I think could directly relate into another sort of future collaboration that might sort of come knocking on the door.
So Erin, as you're describing these various projects, that actually makes me think about a question about, it's clear that you use computational tools, and you talked about database. And so I'm wondering if you have any advice for folks in terms of like programming languages, database skills that they should acquire sort of early on in their career.
Yeah, so it's interesting. I mean, the times have definitely changed. When I graduated with my undergrad, I had never programmed up just a traditional regression model using software at all. And the times have definitely changed. And so our undergraduate students now are being sort of thrown at R and SAS and all the different sort of tools like that. I'd say currently, at least in the academic setting, R as a computing language is probably the most important. But really, if you know one or you have the ability or you've experienced learning one, I'd like to say you could sort of more easily, I don't want to say easily, but more easily pick up a second and a third and a fourth. And it seems like right now I'd probably argue that Python is becoming one of the most popular sort of second or third languages to be learned. But again, it sort of depends on what your future direction is going to be. I know that SAS is still a big component when you think about from the medical arena or even industry jobs. Definitely want to see some SAS experience. And so I definitely wouldn't focus on just one, but start building up at least sort of the walking knowledge of a few of them if you can. But particularly as an undergrad, if you walk out of undergrad with feeling pretty comfortable within one language, I think throughout your graduate career, you'll be able to learn sort of the other ones as you go and as you need to. Again, C or C++ definitely comes into play with big computing, but I think Python is really maybe where that's turning now.
That's a constant topic of discussion that I see in our online community and elsewhere, which languages to use and learn and for what.
Yeah, and it's actually hard. I mean, we talk about that even as a faculty a lot of what languages we should be teaching our courses in, because again, if you're going to stay in academia, R sort of seems to be the one, and again, Python as an extension would be great. But if you're going industry or government, then SAS sort of becomes the way, and tailoring your classes appropriately becomes sort of an important aspect as well.
So that makes me think we should have asked what's your favorite class to teach.
Oh, wow, great. Yeah. Oh, good one. I would say
picking your favorite child, right? No.
no, not at all, not at all. But yeah, so I really like teaching sort of the applied regression classes, so applied linear models, statistical models. Currently, I'm teaching spatial stats, which again is where some of my research interest and passion lies, and so that's obviously been just a fun class to teach, just because I have a lot of the examples that I've mentioned while talking with you all that sort of fall in that area. But just I would argue that the applied statistical modeling class is probably my favorite, and it's an R-based class, and so some students have some R experience, and some of them are brand new, and so it's definitely a challenging class to teach from that aspect. Is you're giving enough sort of example code to see what we're trying to do, but it's not a matter of just hitting run on the code to make it work. It still takes the students quite a bit of time and effort to get the code tailored towards what they're needing to do in their sort of labs and in their homework assignments. Yeah, but I think maybe not in terms of particular class, but just in terms of students, I teach a lot of undergraduates and a lot of graduate students from non-statistics seeking, non-statistics seeking students. So I have a lot of master's and PhD students from the environmental sciences and really just across the university, quantitative psychology, et cetera. And so it's been fun to also then just continue to extend some of these collaborations and learn about what they're working on it as well. And so that's just been sort of a fun way to meet more people across campus.
Well, this has been great. Thank you so much.
Absolutely.
Yeah.
Thank you for taking the time to chat with me.